Founded in 1946, Radio Frequency Company's 40,000 square foot design and manufacturing facility is located in the suburbs of Boston, Massachusetts, alongside of the historic Charles River. RFC is the world's leading manufacturer of advanced industrial RF processing systems for the rapid heating, drying, curing, disinfestation, and pasteurization of food products and industrial materials. This presentation will primarily cover the application of radio frequency in the baking process and its effect on moisture uniformity and checking, but will also touch on what it is, how it works, and how it can increase the overall efficiency of the baking process. Here we have the electromagnetic energy spectrum with visible light toward the center. To the right we have increasing frequencies and higher energy levels out towards X-rays and gamma rays, which are both forms of ionizing radiation, often referred to as irradiation when applied to foods. To the left we have decreasing frequencies and decreasing energy toward microwave and lower yet radio waves. Both microwave and RF are forms of non-ionizing radiation, and not to be confused with irradiation. RF heating is a thermal process caused by a non-ionizing electromagnetic form of energy, just like an FM radio transmitter. The USDA does not view the RF thermal process as an added ingredient. Therefore, an organic product treated with RF can carry the certified organic label. The FDA does not view the RF thermal process as invalidating the application of natural on the label, unlike irradiation, which is considered an additive and therefore requires approval and special labeling. How radio frequency heating works. The unique structure of the magnetically polar water molecule, H2O, is the basis for the thermal response of water when subjected to an alternating RF energy field. In a radio frequency heating system, the RF generator creates an alternating electric field between two electrodes, above and below the conveyor. It's easy to think of the behavior of a polar water molecule in an alternating electrical field being much like the same as how a bar magnet would behave in an alternating magnetic field, changing orientation to face the opposite pole. For 60 years, radio frequency drying has been proven in post-baking dryers, where this technology has increased the traditional conveyorized oven efficiency and throughput capacity by as much as 50%. RF eliminates checking and overcoloring, improves shelf life, and also minimizes water activity both in human and pet foods. RF is not a new technology, but a constantly improving technology, and one where capital costs are actually coming down, and systems are available for smaller lines, where once it was employed only for higher capacity lines where the ROI was stronger. Looking at the traditional baking process, without RF, it can be divided into 3 stages. Depicted at the bottom of the slide is a 7-zone DGF convection oven for the production of snack crackers. In the first third, we have the product development stage, where loft is typically developed. The second stage we'll call the baking stage, where crumb structure is commonly set. And the final stage, where the color is developed and final moisture content is achieved. How is the baking process changed when adding an RF post-baking dryer? Here we have the same 7-zone DGF convection oven, followed by a 2-zone 200 kilowatt radio frequency dryer. The stages are only slightly changed, yet the result is quite remarkable. So the order remains the same: product development first, baking stage second, color and preliminary drying in the third and final oven stage, and the additional 4th stage is final drying via RF. Typically, we're looking at no more than 4 to 5% from the target package moisture content. This is an actual line and the actual outcome. What happened with this product on this exact line is as follows. First, we achieved a 22% increase in output capacity simply by eliminating the oven's responsibility for final drying. Without the RF, 6,250 pounds per hour could be produced within spec. After the RF, the output was increased to 8,000 pounds per hour. That's 1,750 additional pounds per hour. And if we carry that out to a 6,000-hour year, 10,500,000 additional pounds can be produced. And yes, checking and overcoloring are virtually eliminated. So yes, RF is a very effective tool to combat checking issues, but just as significantly, it's a much more efficient way to produce many types of products. How is this possible? As a baked product develops crumb structure and loses moisture content, it becomes less of a thermal conductor and a greater thermal insulator. Conventional drying decreases in efficiency at this point. If you look at a typical drying curve in a conventional oven, efficiencies trail off dramatically in the final drying stage. Radio frequency drying has the unique capability to preferentially heat the moist interior of a product with 100% efficiency and create a uniform moisture profile throughout the thickness of a baked product, thus its effect on checking. This illustration depicts a baked product within an RF post-baking dryer. Note the predominance of moisture is located in the interior of the product in the final stages of baking. Here, it can be selectively targeted and removed in seconds with 100% efficiency. Here are our little polar water molecules again, constantly reorienting themselves to face the opposite poles. Conventional ovens require a prolonged resistance time for baking products to reach their final interior dryness target. Because the thermal transfer efficiency at this stage is low, productivity is limited. RF post-baking dryers eliminate the interior drying requirement from the oven, enabling as much as 50% increase in band speed. RF energy preferentially heats and dries only the moist interior of the baked product with 100% efficiency and eliminates checking. Microwave drying eliminates checking caused by differential moisture content and shrinkage. The radio frequency dryer advantage is summarized as follows. An RF dryer will automatically adjust power in accordance with the moisture content of the product going through it. On the left is the generator frequency, fixed at 40.68 MHz. On the right is the applicator frequency. The product travels through the RF applicator between the electrode array. Think of the generator as a radio frequency transmitter and the applicator as a radio receiver or antenna. As the graph shows, when these two frequencies don't match, there is very little power transferred from the generator to the applicator. What makes the applicator shift frequency and match up to generator is the water within bakery products. That water represents a capacitance value, and with basic antenna theory, we know that when you add capacitance to an antenna, you suppress its resonant frequency. So basically, more water, more power. Less water, less power. This means that a very tight final moisture spec can be maintained, even if there are moisture variations on the incoming product. Typical types of products with high percentage of checking: fat-free crackers, flatbreads, crackers with inclusions, bread dough-based crackers, for example, pita chips, gluten-free, co-extruded treats. RFC now offers economical units available for smaller throughput requirements with air-cooled design for low capital, installation, and maintenance costs, as well as simple, robust designs with the same processing benefits of our larger systems. The benefits of RF post-baking drying include increased productivity up to 50% or more, unit energy cost reduction, improved floor space to productivity ratio, lower carbon emissions, excellent control of moisture content and uniformity, virtually eliminate checking, improve shelf life, independent control of color and moisture content, improve flavor retention.